Assalamu alaikum. Samir Soge with you. More than 10 years back, I had written an article about multicast streaming using GNS3 and VirtualBox. Today, I'm going to walk you through how to simulate a real multicast streaming environment using EVE-NG with actual video traffic using VLC Media Player. Because back then, it was just images of the actual video stream. Now, on this YouTube video, we are going to see the live stream. Instead of auto RP, we'll be using BSR in this sparse mode setup. We'll be using BSR for few reasons. Auto RP needs more configuration as compared to BSR. This is because RP information is given out via multicast in auto RP. So how the routers will receive this information when there is no working multicast setup. So just to receive this RP information, you will have to run PIM dense mode. Well, not exactly, but when you do auto RP listener, you are doing just that. The other reason is that BSR is open standards. The third is since in this lab I put a router with iOS XR to get hands-on experience with it, we'll run BSR on it. Our lab consists of six Cisco routers. Five of them are iOS Classic, and the sixth one is iOS XR. This iOS XR router is the RP candidate as well as mapping agent. Uh, we have two VMs. One will be the source for the multicast stream, and one will be the receiver. Both are Ubuntu VMs. PIM Sparse Mode is configured on all connected interfaces. We are running OSPF on all the interfaces, including loopback. Let's see the router configuration. All the routers have very similar configuration. So we have this command which is basically running OSPF on all interfaces. You can see all the physical interfaces which are up. We are running PIM sparse mode on that. Let's see the BSR candidate configuration and RP candidate configuration. So we are running multicast routing on the router. Similarly for other router as well. Let's see, show. We have enabled multicast routing over on all routers. So we have multicast routing enabled. We have PIM running on the physical interfaces. Although it is not showing, but PIM must be running on the loopback. See, it is mentioned loopback. Okay. After that, we are running the RP candidate, which is the loopback IP of 6.6.6.6, and this is also the mapping agent, which is BSR candidate at 6.6.6.6. We can see the RP from another router. Okay, we can also see the mapping agent from here. Okay, so 6.6.6.6 is the BSR. Now let's go to the Linux VMs. First we'll go to the receiver, and we will receive the stream and we will see its effect on R5. Before that, let's verify IP connectivity. So this is 100.100.2.2. Let's go to the server and ping 100.100.2.2. Okay, so we are able to ping. Let's start the stream. So basically what this command does is it is running VLC, and it will take an input stream at 239.255.1.1 multicast IP address, and UDP port 1234. We have to select the interface on which it will send IGMP out. Uh, this is important if you have multiple interfaces on the system. So I'm using the command line of VLC because the GUI of VLC does not have the option for physical interface selection. So let's run the command. Let's go to R5 and see what's the effect of this command. Okay, so here we can see that the router received the IGMP message, the multicast group of 239.255.1.1 over the Ethernet 0/2, which is this interface. And you can see the device which sent the IGMP message, which is 100.100.2.2, which is the receiver. Now let's go to the source of the multicast stream and start the multicast stream. So we will see that the video file is present over here. Let's see the command. So here again we are using the command line VLC. We will loop the video, sample video, okay, because the video is pretty short, so it's better to loop it. The stream out will be duplicated as we want to not only send the stream out to 239.255.1.1 on port 1234, but also we would prefer to see the video what is going on. Here again we are selecting the physical interface, or else the stream might not work if it is going out via the wrong interface. We are setting the TTL as 10 because after that the stream will not reach the receiver. Our network is pretty small. Even if you consider the max hops 1, 2, 3, 4, 5, 6, 10 is fine. 10 will do. Okay, let's start the stream. So this is the big buck bunny. Okay, let's see whether we are receiving. We are receiving on the receiver as well the same stream, and you can see it is whatever is streaming out from there, we are receiving it over here. So let's again go back to the router and see show IPM route. Okay, so we can see the multicast route for 239.255.1.1. For all groups, it has to go to 6.6.6.6. This is how shared path tree works. Okay, so basically your IGMP will go over here, okay, on R5. R5 will send the message to the RP, okay, and then whenever the RP receives the multicast stream, let's say the multicast stream is coming from here to here to here to here, okay, when it will receive the stream, then it will forward that stream to the receiver. Then what happens is, when the receiver comes to know the source IP address of the stream, when the router R5 comes to know the source IP address of the stream, it will request directly the stream from the source. In that case, what will happen is, as soon as it will get the stream from the source directly, okay, it will send a prune on this, because there is no need to receive two streams for the exact same content. Okay, and I purposely put the RP candidate in at a place which is suboptimal, so that it will have to cross the network via multiple hops, and then the receiver will receive it. But when the router R5 comes to know that the source is closer, okay, it knows the IP address of the source, then it will send to it directly, and the stream will come directly via R1, R3, R5, and then to the receiver. One more thing we can do here is we have seen the configuration of RB candidate and mapping agent on an iOS XR router. Let's remove that and put it on a classic iOS so that you can see both. We have to commit it. Okay, we will lose the RP now. Okay, in 2 minutes time we will lose the RP because there is an expiry to this. In the meantime, let's configure router R4 as the new RP and mapping agent. Okay, IP PIM RP candidate. We have loopback 0. Okay, it's saying that we need to enable PIM on loopback 0. As I said before, that this interface on the iOS XR is running PIM Sparse Mode. We'll do the same on this one. So you can see the loopback is a part of PIM Sparse Mode now. Let's just go and see whether we lost the RP or still we have a minute more to go. Anyway, we will start with the R4 configuration. Okay, IP PIM RP candidate loopback 0. Loopback 0. Okay. Let's go to R5 and see the status now. We are still having that. We should get the new RP. Yes, we got the new RP. Show IPM route. It's reflecting over here as well in the show IPM route. But we have still not received the I think the multicast stream stopped. Over here it is running, over here it has stopped. Let's break it and start again. Okay, so over the new RP as well, the multicast stream is working. One thing which happens in multicast network is that if you have multicast running on a network which is having redundancy, okay, it will not send the request out via all the interfaces, all the redundant interfaces. It will do something called an RPF check, which means the source of the multicast traffic will be looked into in the routing table, and if the stream is coming via an interface via which it has a back route for, that stream will be allowed, other stream will not be allowed. In case if you have asymmetric routing, something like that, you will have to put a static multicast route to fulfill this RPF check. In larger environments, BGP can also be run for multicast. The role of BGP is not for routing table or for streaming of multicast traffic. It is just for passing the RPF check. So in this video, we've seen that EVE-NG makes it easy to test multicast in a virtual environment. VLC provides real RTP streams. BSR simplifies RP advertisement. You get end-to-end real multicast behavior. Thanks for watching. If you found this helpful, hit like and subscribe for more deep dive labs. And don't hit the bell icon because life is more important.